And we're live.
Good to be back. Little 1 week hiatus. It's good to be back on. Hope everyone enjoyed last week's one as well. What was it you guys covered last week, Darren?
I think it was myself and Mark last week. We did artificial intelligence, like touching on different aspects of that, including machine learning.
Nice. So yeah, I think we'll cover a bit of that again today, but looking more at the kind of data scientist responsibilities, and then obviously what a data engineer does and how they fit into it. I think the versus title is probably a little bit misleading. I don't think it's necessarily a either or like they're competing against each other. They very much work hand in hand. You don't really have data science without data engineers, and vice versa. But I think I think the reason we kind of tagged it up as versus is because often there's a bit of lack of understanding of what sits with data science, what sits with data engineers. So I think today what we're going to try and do is clear up what a data scientist does, what a data engineer does, where the overlap is, and kind of how those two kind of work together. So it's definitely not them against. They very much work in harmony.
Great, thanks, Phil, mate. Certainly not an adversarial relationship, hopefully. Darren, we got a little bit of noise, I think, from your
Yeah, I
machine.
cleared it up. There was something that was making noise, so I've just got rid of it.
Excellent, thank you. So, guys, if you're one of the keen people that's dialed in early, I think we'll give people another minute or so just to get dialed in to overcome the Zoomitis, and then we'll get cracking. And as Phil was just explaining, we're going to talk through today about data science and data engineering. It's Tuesday, so we are back, and I think, no doubt, through popular demand, we've got Phil and Darren with us today to talk you through that. Darren, I have now moved on from Ty King, now on to The Last Dance.
Last Dance is great.
Which episode are you on?
Well, I'm actually a few episodes behind. I've had other tasks that I'm doing at the moment, but I'm very excited to jump straight back into the world of MJ. He's a personal hero of mine. I remember walking around Florida when I was about 7 and begging my dad to get me a MJ jersey that I still have at my family home. So
and it still fits, I'm sure.
Yeah, absolutely. Yeah, I've not grown much.
Yeah, I think I'm on episode 3 out of about 8. I think that's available in the UK at the moment. But don't spoil it for me. I don't want to find out if he wins that 6th championship or not.
Mm-hmm. Yeah, I haven't actually started yet. Charlotte's on night shift Wednesday, Thursday, Friday. So I think that's what I'll be doing Wednesday, Thursday, Friday evenings. Basically working my way through that. She's not got much interest in it. So yeah, nice one to save for when I've got a bit of spare time.
Yeah, I think the youngest myself maybe missed out on some of the Dennis Rodman stories. So it's interesting to get those as an adult now. Yeah. Guys, I think 2 minutes and counting past 12, we might be almost ready. What do we think, guys?
Yeah, I think let's dive in. We've got the intro stuff to cover off anyway, so it gives people a few more minutes to join before we get into the content.
Cool. So, guys, it is Tuesday, which is now going to be our regular slot. Tuesday, no longer the most depressing day of the week, because it's now going to be Tuesday when you get your weekly dose of talent tech recruitment. Delighted to be joined by Phil and Darren, as I said a few moments ago, back due to popular demand, and they're going to be talking to us through data science and data engineering, the overlaps between the two, the differences between the two, and helping you to understand the candidates you're going to be engaging with through the recruitment process for your various companies. If I can get my cursor key to work, we will go on to the next slide any moment now. Really excited to be talking about this subject today because it allows me to put up pictures of 2 of my favourite films. You've got on the left The Big Short and Moneyball. And so if, like me, you think of yourself as some sort of unicorn hybrid of Christian Bale, Brad Pitt, with a little sprinkle of Ryan Gosling, then this is going to be the session for you. Housekeeping as usual, just a reminder, you can join us on Slack, and Phil is going to be hosting another Ask Me Anything session. So We get lots of questions and comments through the section now. Just a reminder to put those into the chat or the Q&A function. If you're using the comments, please do use all panelists and attendees so everyone can see your comments as well and weigh in on that conversation. And we'll continue that dialogue and be available to ask any questions that you have got on your minds in the Slack group. Say Phil will be manning a 30-minute AMA session tomorrow at 3 p.m. UK time. I just remind, if you're enjoying the sessions, please tell your friends, and you can catch up on all of the previous sessions on YouTube. Shout us out on Twitter with the handle @HackerJob or LinkedIn, and use the hashtags either TRT or Tech Recruitment Training. So just a final reminder, as each week you'll get a new invite to these sessions, and we're going to try and settle into this regular slot of Tuesday at 12 till 1 p.m. UK time. And next week, reminder coming up is a intro into mobile development. So if you're trying to get your Android or iOS developers, that'll be the session to dial into next Tuesday. So today's agenda, I think I'm now passing over to Darren, who's going to walk us through that today.
Sure. So what we'll do during the first part of the session, because I realised that it's been over a week now since we went through the data landscape, is we'll go through data, but deep diving into data science. I'll take you through some of the tools, etc., and then we'll move on to a couple of slides where we'll talk about what does a data scientist do compared to what data engineering does, and then how they mix and match between the two, and then Phil will take you through data engineering.
Fantastic. And so I think a HackerJob TTR session, not really complete without a Dilbert. So this was, I think, the pick of the bunch from our search for data science, data engineering today. So I think reinforces the need to understand your data. It's so critical for digital businesses now. Always getting some wisdom from Dilbert, I think, very important. So talk us through the recap on data, and Darren, just to bring everyone back up to speed who may have missed our earlier sessions, so we're on the same page.
Yeah, sure. So data teams primarily are made up of different disciplines. So I'll run you through the layers of BI systems in a second, but within the data team, you've got everything from a traditional data team, which would include stuff like business administration, etc. But in a modern data team, what you'll see now is data science, data engineering, potentially a data warehousing team if that responsibility isn't taken by data engineering, and then you'll probably see a data analyst within that team as well, and then you'll have stuff like BI development. So if you look at the layers of the BI systems, the left-hand side is very much focused on the database, cloud storage, etc., separating the files, which is very engineering focused. So ETL is a term that we'll run through a little bit later, but you'll see a lot of that in data engineering. And then you go to the warehouse. So this is people like data warehouse developers. And then as you get towards the right-hand side, here you're talking about data scientists, their data science focused tasks, i.e. reporting and visualizing data in a way that makes sense to the business.
Cool. And I think what we're going to uncover through the course of the session is, although these different roles exist, there's quite a big overlap between the skill sets and functions that they're doing on a day-to-day basis. Fantastic. Exactly. Okay. So let's get cracking with data science then.
Cool. So just for anyone that wasn't involved in the last session, so these are the kind of responsibilities that data scientists would do. They, as they're on the furthest right-hand side of the picture we saw in the last slide, these guys are very focused on business stakeholders. So what they're doing is using data and producing it to business stakeholders so they can make decisions on what the business should do as a whole, whether that's changing an approach of what they're doing, or whether that is moving into a new vertical or discipline, etc. Exploratory data analysis is, again, looking into the data and doing experiments and doing theories and hypotheses based on that data. And then they'll build models which will measure the results. They'll then make adjustments to anything based on what the models have given them back, and then they repeat the process. So a lot of ways it works very similar to how a software engineer works, where you don't just produce a model, test that model, get the conclusion, and then dump everything you've done before. It's a continuous cycle. So it works in a very circular manner, being a data scientist.
Cool. And just maybe an explanation of that, people can go back to our how to build a product session, that sort of design thinking process, very applicable here for data scientists as well. Okay,
Exactly.
cool. So maybe talk us through the different sort of personas or types of data scientists we see in the market at the moment.
Yeah, so this won't necessarily give away job titles that you'll see and how to define different job titles for data scientists. If people want that afterwards, feel free to drop it into the chat and I can give you some examples. But this is the kind of personas of what you'll see, and it came from a different source as you'll see. But what you'll generally see is everyone wants the left-hand side. Everyone wants the legends, the people that are programming experts. They are statistical experts. They are experts in creating models, etc. These people are out in the market, but they were historically around before data science was really a big concept. So you'll find these are the top 1%, if not less than 1%. They're the top 0.4% of the market. So everyone wants them, but they're not always there because they're experts in everything. You then get the generalists that have touched on everything, can do every task, but they're not necessarily experts in any particular area. So where you'd want a generalist is if you firstly are working in a large organization where you want someone who's going to be able to wear multiple hats at different times and be able to plug into different areas as and when you need them. Or if you work in a smaller organization, a little bit like Hacker Job, I guess, where you want someone who can cover all the tasks but won't necessarily go into so much depth. You then get statisticians. A lot of these statisticians you'll find in big banks. So Deutsche Bank, for example, have got a lot of statisticians in there. If anyone wants to find these kind of people, and these guys are focused primarily on the data. So they are, as the title gives away, the mathematicians. They love looking at data sets and then coming up with conclusions from them, but they won't necessarily be able to do a lot from the programming perspective. You then got the dabblers. So these guys, Phil, having come from a Java background himself, will know a lot about these guys, but you see a lot of software engineers that might touch on machine learning. I had a really interesting call yesterday with one of the clients that say that they want their software engineers to be able to touch MI techniques. So that's what a dabbler is. They're really a software engineer, but they touch on some of the data science tasks. Machine learning engineer is more focused on the modeling, so they'll be using theories that we'll go through a little bit later, like linear regression, and then Bayesian techniques, and then they'll go through predictive modelling as well. You then got the vertical experts that probably have started as a generalist or maybe a statistician, but they focused on one area in particular. So they're a market expert in that particular area. And then you've got the star data science managers. And I think when people think data science manager, a lot of the time that they think, oh, okay, they need to have come from a data science background. Whereas I think a lot of the best managers in data science actually have come from a different area, have an appreciation for data science, but really they're very much like an engineering manager where they're not going to be hands-on doing a lot of the data science techniques. They just need to have an appreciation and then be pushing the team to get the right results. So that's kind of the makeup of different personas.
Oh, that's really interesting, Darren. So I think one observation here is you talked about sort of the investment banks, statisticians.
Yep.
I think what we've seen over the last sort of 20 years is a lot of this top technical talent and science talent that maybe traditionally would have masters or PhDs and going into investment banking and those sort of quantitative analyst roles, and now like being sucked up by the big tech giants and going to Silicon Valley or tech startups in London or other big tech companies.
Agreed. Yeah, agreed.
Cool. So moving on. So maybe just talk us through some of the key technologies that we're seeing candidates use today.
Yeah, so I've put examples of what I see as the tools that are most used, and then alternatives just so everyone gets the structure of this page. So data acquisition and data cleansing tools, what they are essentially doing is they're tools to help remove duplications, identify any errors, standardizing data sets, etc. So the big player in this market is Talend, but you also see stuff like Octopath or Mazenda. Visualization tools, so this is the bread and butter of what everyone thinks when they think data analysts and data scientists. So these are tools where you can turn raw data into a graph or a chart or or something visual, so that a business stakeholder can define what are we looking to get from this, or what have we got from this data set. So the big player in the market is Tableau. We also see stuff like ClickSense or ClickView, Power BI, and then Looker. MI frameworks, a framework like we go through in software engineering, is a library of tools or areas where you can not start from ground zero every time. So JavaScript, think React. So that's essentially what TensorFlow is. We also see stuff like PyTorch or Fino. And then cloud technologies, I'm sure everyone knows what a cloud technology is, but the leader from a data science perspective, as in software engineering, is AWS, but you'll see stuff like Azure and GCP. Then there's
cool. So our old friend AWS making an appearance once again. So
always.
And so then there's also this overlap with programming languages as well.
Yeah, exactly. So from a programming language perspective, you'll see a lot of Python, or at least we do in our client base. And then, Phil, I don't know, you might be able to jump in here, but I would say Scala is probably the one we see the next most, and then Java after that. Would you agree or disagree, Phil?
Yeah, definitely in terms of a demand. I mean, you'll see a lot of companies that are happy to upskill from Java to Scala. We've obviously touched on the whole JVM family a few times previously. If you want more detail on that, I think the modern software engineering, so I think the 5th presentation we did really kind of delves into that relationship between Java and Scala. But yeah, in terms of the demand on the market, yeah, Scala I'd say is probably the next one. And then you see a bit of R as well, although that is fading. We're going to touch on that a little bit later on the kind of the R's kind of losing prominence. And then within data engineering, there's also Julia, which I'll touch on a little bit later as well.
Cool. So once you get past programming languages, you've then got non-relational databases. So these are databases that don't follow the structure of columns and rows. Compared to the other ones, and I'm not an expert, and I wouldn't say claim to be, but I think that when you're looking at non-relational databases, a choice is less on, okay, I prefer this, and more on what you're trying to do with it. So MongoDB is for certain non-relational decisions, and then you've got alternatives like Redis and Couchbase, and then you've got cluster computing frameworks. There's a lot of talking in this. The most common one you will see is Spark, but alternatives is stuff like Hive and Splunk. Great.
Yeah, and again, we're going to touch, I'll dive in a bit more into Apache Spark a little bit later. But yeah, on the databases, you're I think it's not always the case, but as a general rule of thumb, if all you're working with is like numerical data, chances are you can probably do that within a relational database. If you're looking for averages, add this, minus this, okay, you know, give me the trends in different kind of like sales figures or something like that.
Yep.
When you're looking to add complexity to the data, so maybe it's words, like I think last time you used the example of kind of like Manchester United football players, where you know you're going to have data points, some of which are words, some of which are heights, some of which are all sorts of different data. When you're adding that level of complexity, that's generally when you're going to need a non-relational database. Not always the case, but it's a good way to think about it.
Exactly.
Cool. Okie dokie. So now you're going to talk to us, Darren, I think, about some of these methodologies as well. So we're getting quite deep actually here. So yeah, touching on some quite complex concepts, but yeah, hit us.
Cool. So predictive modeling, anyone that listened to the last webinar that I was on will know about predictive modeling, but predictive modeling essentially is looking at something that's happened before and then looking at the likely outcomes of it. So Netflix are probably the best example of predictive modeling, where they will look at, you have watched X film, there is a correlation between the people that enjoy this film and the people that have enjoyed Y film, and the predictive modeling will start pushing you towards those decisions, so that you then are enjoying their films and you keep coming back. So that's how predictive modeling works.
Right. Okay. Next up,
you've got linear regression. This is probably the oldest of the concepts, although decision trees may have come around first. But linear regression is the best way to describe it is looking at it from a classroom perspective. So it's looking at two variables, and then what is the optimum one or where is the optimum line? So if you're looking at it from classroom perspective, you would look at it somewhere like how much time do you spend studying in order to reach this result in your GCSEs. And the mean line might be that you want people to hit a C. So then you would look at the variables of time spent and the result achieved, and then you would work out the mean line for this is how much time you would need to spend in order to achieve this result.
Great. Yeah, I think this. I think the picture chosen here like explains the concept quite well. Great. Decision trees. Talk us through this one.
Decision trees, something that sounds very complicated, but I put a picture on here to explain exactly what it is. This is really how simple decision trees are. So they are looking at a outcome that you want to achieve, and they will look at the variables and almost go, you could put it down to yes, no, or as you'll see on this picture, they go more in terms of playing tennis and then the outcome you're trying to do. So they would look at the outlook. So it's sunny. What is the humidity? Okay, the humidity is high, so I don't want to play tennis. Or the humidity might be normal, and then you do want to play tennis. So really, it's as simple as that, of looking at the different variables that might happen. What is the variable, and like where will this push you in terms of the results you want to take based on that?
Cool. And naive Bayes, more obscure one, but go for it.
Yes, this is the most complicated one for me. So naive Bayes is essentially looking at the probability of an event, and then looking at, based on prior knowledge and then conditions, what will be the result of that. So I'm trying to think of an example because I don't have one up for this. So for this, look at let's look at an e-commerce website. So based on I'm trying to purchase this item, what is the outcome that we need to do to get to this? So where do we need to push our customer base around the website in order for them to end up purchasing a product? So you could look at, okay, if we push them to the basket straight away, they may not come back to purchase more items. Or should we advise that, hey, so you've seen this item, would you be interested in buying this item as well? So it's looking at the decisions that a customer can make in order to produce the best outcome for that business.
So
hopefully that made sense, because I kind of curveballed there.
No, I think it does. I think it's kind of the next step from predictive modeling, right? Like you use your predictive modeling to say, okay, customers who buy this item tend to buy this item, and then your naive Bayes is then you're going to then blend that and work out, okay, how can we direct the people that are going to buy this item towards this other item, because we know there's a correlation there. So yeah, no, I think that makes sense.
Exactly, and I think a lot of don't think that these theories will be used in isolation. Yeah. Most of the time, data scientists will be using these 4 plus probably another 30. So they're all like a software engineer would be doing. They are doing different things together to achieve the best outcome. So they're using the model or theory that works best for the outcome they're trying to achieve, rather than using everything in isolation.
Yeah, and I think it's one of those where the more data you have, the more kind of surety you can make decisions with. Like it's the same in everything. It's the same in social science and all sorts of research. Exactly. You never run one study, take the first answer, and go, well, this must be true. You delve into that data and you run as many different analyses as you can, and you put it all together and you say, based on X amount of different sort of projects we've run, X amount of analysis we've run, this is the most likely outcome.
Agreed.
I was just checking for Google if where the name came from, but I can't see if there was a Dr. Bayes or not.
It does come from a Bayes theorem, and then they've added on to it.
Okay, so there's a bit more research next time on my part, and I'll be able to have a pithy comment. But so talk us through some of. So we've had the Moneyball mentioned earlier, but these techniques used in a lot of real life examples now. Maybe just talk us through some of those examples.
Yeah, so I'll take you through them one by one. But healthcare, I was going to put an example, but NHS, like healthcare is kind of the NHS in British terms. So the NHS will be using data science from a imaging perspective. So what they can do now is they can use stuff like MRIs, should I say, X-rays, etc., to detect potential organic organ failures, or does this person have a likelihood of a tumour, i.e. results that will come if they don't sort out problems. retail, you can look at supermarkets. I kind of took you through the example a minute ago, but essentially they will use data to work out the best outcome from a spend perspective. Entertainment, Netflix, again, I won't take you through that. Cybersecurity, so this is looking at how they can use data to work alongside their penetration testers, who will essentially be trying to stop hacking. So they'll work with their penetration testers to work out, based on the data they've got, where is the likely area that people will penetrate into their systems to break them, and then they'll direct the testing team towards there. The Moneyball, actually, I want you to own this one, Dale, because you're very passionate about Moneyball. So how is data used from a Moneyball perspective?
So Moneyball is talking about Major League Baseball in the US, basically using data analysis, data science approach to understand who are the best players to pick and what combination of players is going to produce the best outcome. You asked about weather, but I thought the other interesting one for healthcare is the current COVID-19 situation. So the reports from Imperial University obviously influenced UK government's decision about implementing lockdowns, that sort of thing. A lot of conjecture about to what extent that's being followed or not, which we won't get into right now. But talk us through the weather example.
Yeah, so weather channels, and there's actually a weather channel as in the US, but the weather channel a lot of time will use decision trees, especially in the Caribbean and Florida states, where they are very hurricane hit, and they'll use decision trees to work out, based on data we've got, if X happens, will we need to evacuate? And they'll have little decision trees to go, okay, if this happens, that will result in this, which will result in that, which means we need to evacuate. Or I don't know, the hurricane is currently at 4. So based on the information we've got for expected weather for the next few weeks, it means you won't need to evacuate. So they'll use a decision tree methodology to make decisions on hurricane hit states on what they should do at that present moment.
Got it. A similar process that the Met Office in the UK, for example, will be using, and a lot of that data then used by lots of different businesses to try and model or map future outcomes for their business. Interesting. So tell us a bit about how much these guys are getting paid.
So this is the best data I could get you from a US perspective, but it gives you a bit of an idea. If anyone that doesn't know, the US is currently the pound is currently at 124, but before COVID it was at 131. So on average, a Microsoft dev in the UK would be getting something like 90 to 95 grand, Amazon around that, Facebook around that, and then IBM 110 works out to be about 80. So this is based on a 4-year plus. So once you get to a 4-year plus commercial experience candidate, you're looking at somewhere in the region of 70 to 100K. And then upwards of that, if you're looking at what we had as legend earlier. So I think that as with anything, the more you ask for, the more expensive these people get.
Cool. And so we were talking about that migration from Wall Street into Silicon Valley, really clear to be seen from some of the names there. So moving on, bit of a gender bias, things similar to software engineering.
Yeah, so this is a very late edition, so Phil and Dale may not have even seen this pie chart yet, but I think it's interesting because oftentimes you'll speak to clients and they'll say, look, we're only really looking to bring people in if they come from a certain background. And that's the reality of the market. There's some people will say, look, we want females in this role, or we want 50% of females. Whereas if you look at how that market is made up, it's 83% male. And this is a global stat for data scientists, primarily looking at Europe and the US, admittedly, but this is what the market looks like as a whole. So you need to be realistic when doing searches that if you are looking for a 50-50 makeup of a shortlist, then you're really cutting out a big proportion of the market. So my advice would be always educating hiring managers on go for the skill set that is the best for you. Don't look to create shortlist based on what you're trying to achieve.
Cool. Or I guess you might achieve that diversity by looking at hiring from within, promoting or getting people with a skill set and training them up, right?
Yeah, and for big
about 1 in
organizations,
5, but but statistically speaking, we'd expect about 1 in 5 to be female in a.
Yeah, and like I would say that organisations that really are passionate about the diversity element start supporting a lot of the STEM courses. Go through that element, start building people up from a junior level. Don't assume that you're going to be able to find a 6+ data scientist with every skill set under the sun, because unfortunately the way the market has been over the last 20 years has been male orientated. So try building up from a junior level with the view of you'll bring these people up into that senior level in a few years' time.
Yeah, I agree.
Cool. And yeah, thanks, Phil. So, and as we saw on the previous slide, increasingly scarce and expensive skill set to be hiring if you want that experience hire. Okay. So talk us through like this piece about what skills are most valuable in the market.
Yeah, so I'll jump through this quite quickly because I'm mindful we're halfway through and Phil's not gotten to his section yet, which I know he's keen to do. But you'll see here there's different skills that are seen more prevalent in the market at the moment, or will push your salary up. So Apache Spark is seen in both data engineering and data science. So that's pushing it up by 17%. Algorithm development, so looking at more the ML engineer stuff as well as the machine learning, will push it up by an average of about 10.5, 11%. But interestingly, stuff like R and SQL is dying out in a lot of ways. That there is new technology that is pushing these out. And if your skill set is primarily based around being a SQL focused or an R focused data scientist, your price point has gone down significantly. So I don't know how many people will get on this call that are actual data scientists, but my advice would be to start moving yourself more towards like a Java or something like that, or a Python.
I think probably quite important to call out these are sort of correlations. So it isn't necessarily causal, but yeah, I think an interesting bit of context for people to think about what skill sets they're investing in, the training courses they might get their talent to be taking in the next year or so. Okay, so key one here. So DS, data science, how does it differ from DE or data engineering?
Cool.
So I think this is a two-header then. So I think if we extend the MBA concept, it's maybe data scientists. Are they the Jordans, Scottie Pippins, and data engineers are the Dennis Rodmans?
Yep, or Larry Birds.
Great. So talk through the distinction, guys. Then.
Cool. Yeah, I mean, it's kind of what it says on the tin here. Data engineers develop, construct, test, and maintain architectures such as databases and large-scale processing systems. So essentially, they're in charge of the infrastructure that kind of generates the data that a data scientist is then gonna use.
Yeah, exactly. And data scientists will be building and developing insights and building the models so that the business can use them. I think the left and right is a good way to look at it. The left-hand side is when this is all in raw form, and then the right-hand side is turning it into a business-focused form.
Yeah.
Cool. Okay, and so just comparing their responsibilities, talk us through this.
So to be honest, we're going to dive into this in a little bit more detail throughout the presentation, but I think this is a really good graphic to have. So this is probably one, when we send out the PowerPoint, the presentation afterwards, definitely worth kind of having a look at these, especially if this is an area you're recruiting for, and just make sure you're familiar with both sides. But I mean, I'm going to touch on a lot of this data engineering stuff as we go through anyway, and I think Darren's already touched on a lot of that data science.
Cool, okay,
yep.
So just
I think we can move on.
Maybe for reference later. And I think what this is kind of showing is there is a bit overlap between those tools, and in some instances you may even see that candidates are a hybrid of those two functions, right?
Yeah,
yep,
absolutely.
Exactly.
Cool. So if we move swiftly on, but I think one to reference back in the deck, guys, we said we're going to get the PDF later. So Phil, drum roll then. So walk us through, or guys, we got any Q&A that come through we want to tackle at this point?
No,
everyone's been very quiet today.
Okay, clearly being incredibly thorough. But guys, if you do have questions, do put them into the chat, or say if you're shy, join us on Slack either later today or tomorrow, and Phil will be available. So Phil, talk us a bit through the data engineering part sides.
Yes, if we jump on to the next, lovely. So I think this is a nice, simple explanation. So data engineers make sure the data the organization is using is clean, reliable, and prepared for whatever use case may present themselves. So data engineers wrangle data into a state that can then have queries run against it by data scientists. So Yeah, I think that's a nice, simple explanation. They're cleaning it, they're making sure that the relevant data comes through, and kind of that they're not pulling everything through and giving the data scientists a data set that's far too large and contains loads of information that they don't necessarily need. So they're picking out the right data, packaging it quite nicely, handing it over to the data scientist, who can then basically make sense of it, as Darren's kind of already touched on.
Cool. Okay.
Cool. So a bit similar to data scientists, there are kind of different personas out there. So I did a bit of research. According to DataQuest, there are 3 main personas out there. So again, generalists. So generalists are typically found in small teams or smaller companies. In this setting, data engineers wear lots of different hats as one of the few data-focused people in the company. So really similar, to be honest, to the data scientist generalist role. Now, again, similar to data scientists, you might need someone a bit more senior who does have a bit more in-depth knowledge, who maybe can set the leadership within your data policy and can really sort of define how you're going to use that data in general. But in terms of working on it day to day, for a smaller organization, often a generalist would be the route to go down. So they can do everything from kind of managing the data and analyzing it. And it's a really good role for anyone who's looking to transition from data science to data engineering, since smaller businesses kind of won't worry as much about engineering for scale, which is one of the biggest challenges.
Okay, so maybe that people transitioning into data science roles start off as more of these more generalist or hybrid roles.
Yeah, and vice versa.
Engineering and skill up and then go into more specialized role in a large organization, possibly sometimes. Okay, so talk to the difference between pipeline centric and database centric then.
Yeah, absolutely. And by the way, as with all of this, these aren't exactly hard and fast rules. You will find a blend of these between all different companies, but pipeline-centric data engineers are often found in mid-sized companies. So they work alongside data scientists. So primarily in a company where you've got enough budget and enough headcount to have a full team of data scientists and data engineers to help make the data they collect a bit more usable. So they'll need an in-depth knowledge of distributed systems and computer science to make sure that they've got that really smooth pipeline through to the data scientists, so the data scientists can be kind of churning through that data. And then finally, you've got database centric. So typically found in larger organizations where they'll be managing the flow of data. It's a full-time job. So literally their whole day is just making sure that there's a smooth flow of data to the scientists. They work with data warehouses across multiple different databases, and they're responsible for developing table schemas. So kind of going back to what Darren said about only certain businesses would have data warehousing teams, typically larger ones where they're dealing with huge amount of data. And within those companies, you typically have more database-centric data engineers.
Yeah, and I think we might have touched upon this in an earlier session, but a big explosion in startups that are trying to provide tool sets to these guys to help them manage these big data sets and to combine those data sets between many different sources. So I think you may have got sales data or internal product data to try and map those things together and create insights for the business. So yeah, really interesting space. Talk through some of those more sort of day-to-day responsibilities then, Phil.
Yeah, absolutely. So we've touched on it already, but they develop, construct, test, and maintain architectures. So that's architectures focused around data extraction or generation. They align that architecture with the business requirements, so they make sure that they're pulling the right information that the business requires. They're obviously involved in the data acquisition process itself, so they can actually be involved in searching out that data. They'll identify new ways to kind of improve the reliability of the data, the efficiency, the quality of it. Obviously, again, working with and that's when we come back to kind of the design-focused approach and constantly iterating. So the data scientist might notice flaws in the data or that it's not as comprehensive, and then they can work with the data engineer to try and make sure that they're covering off those bases. They'll conduct research for industry and business questions, deploy sophisticated analytics programs, machine learning, statistical methods, working alongside the DS team. They'll use data to discover which tasks can be automated. So again, we can see there how it could maybe work with the DevOps team or any of your internal automation that you've got going on. And they'll deliver updates to stakeholders based on analytics. So it's not just pulling data through. They play a huge role in kind of optimizing the business, as well as obviously giving insights to the industry in general.
Cool. So maybe talk us through, say, similar story I think that we've seen in DevOps and some of the other roles we've touched upon. There's been an evolution in data engineering. Maybe talk us a bit of that, Phil.
Yeah, absolutely. If we skip. So this isn't, I wouldn't say this is the very start of data engineering. I think Mark gave a really good insight into kind of the history of AI, the history of data science the other day, which I'd recommend going back and having a listen to if you haven't already. But ETL is kind of the first well-recognized data engineer discipline, I would say, when really data engineers became a thing unto themselves, rather than something that a DBA might do, or a database developer, or even your software devs back in the day. So it's short for extract, transform, load. So there are three different database functions that are combined into one tool to pull data out of one database and place it into another database. So again, kind of like going back to what Darren was saying a little bit before, when we're talking about like numerical data and things like that, if you're running analysis on, vast swathes of numerical data that you've kind of taken in through your transactions, you might want to pull certain elements of that out. So you might want to pull out, I don't know, the Q2 data or something like that to see how, going back to, again, statistical mapping of weather and things like that, how does the weather changing from winter from March through to June, how does that affect sales, I don't know, of certain products that are maybe related to the outdoors? Or you might want to be looking at a certain subset of your retail base in other areas. So it allows you to focus in on small areas, pull that data out, and give that to your data scientist to then kind of make sense of. So it's very manual, and it's quite specific as well.
Cool. And so talk us through that evolution a bit further then.
Yeah, absolutely. So in terms of the evolution between the three, so obviously we can see here traditional ETL has quite high latency. So we touched on latency a few weeks ago as well. That's basically the delay before the transfer of data begins, or the delay in general. So you can have latency within software engineering, which is the delay in your system doing things. Latency in terms of data engineering is the delay before you start to actually pull that data. So it's a little bit slower. It's on disk as well. So basically what that means is the data is stored in clusters within a disk. So it's a little bit restrictive in terms of the amount of data that you can use using a kind of traditional ETL pipeline. And it's mainly designed for databases. Then we move into logical replication. So logical replication, as we can see, it's real time or low latency, so less delays, and obviously real time. So you're getting constantly updated, but it lacks the transformational capacity. So basically what it does is it allows you to replicate a subset while it basically only updates anything that's changed. So again, if you go back to your, let's say you were pulling out your Q2 sales figures, maybe you want to look at them midway through the quarter and then at the end of the quarter. What logical replication would allow you to do is run the same process of pulling that data in, let's say, mid-April, and then again, in mid-May, and then again at the end of June. What it'll do is it'll only update the things that have changed. So it's a lot quicker, and it allows you to make sure that you are updating anything that has changed in that time without having to pull all of the data through itself. But again, it's not fully real time. It's not updating, on a daily basis, which is what you're looking for really when it comes to real-time streaming. So this is where we are now. So real-time streaming combines the low latency of the logical replication with the transformation capacity capabilities of ETL. So the capabilities to pull out certain sections and manipulate that a little bit better. It performs inline transformations in the memory, so it's constantly transforming the data as it's going through the pipeline, and it can support not just databases, but data you're collecting from all sorts of sources, which we should be able to see on the next slide.
Okay, here we go.
Great. So yeah, real-time data streaming is the process by which big volumes of data are processed quickly, such as that firm extracting that info from the data can react to changing conditions in real time. So your data from Netflix, any data from your phone, any data collected from any kind of IoT, so smartwatches, whatever that may be. It's data that's constantly being streamed in from the connected devices. It's processed through a real-time API, passed into the servers, and then obviously you can see that within your visualization. So it's constantly updating in real time, and that's kind of where we are at the moment, which is obviously, you know, hugely beneficial to companies, the fact that they can get this information almost instantly, rather than having to rely on the data engineers to go into a database, extract it, transform it, load it into another database, then a data scientist to actually look through it. This is the kind of automated stage we're at, where a data engineer has built a really, really good infrastructure and a really good automated pipeline. Data scientist has built a really nice visualization framework, visualization screen. So that data is just going straight into there, and you're able to kind of assess and pull the meaning out of it straight away, which is really cool.
I think important probably to stress here is that this is technically possible, but not necessarily realized by every organization in every single use case, right?
Yeah, absolutely. Yeah, it's definitely the advanced end. I think we're going to come on to some use cases in a second.
Great. Okay. So this just talks through this diagram then, Phil.
Yeah, again, so it's kind of what I've just gone over, but it presents it in a bit more of a detailed way. So we see here down the sides, you've got Internet of Things, you've got Raspberry Pi, you've got the cloud with all of its various devices connected to it. You've got traditional databases, so all the different ways that data can come in. You can see that's ingested by a system. So you can think of these stages along the top as the data engineer, data science pipeline. So data has been ingested, it's then being processed. So this would kind of be the data engineering stage of taking that data in, processing it, storing it, which is when it's kind of handed over to the data scientist. And then obviously the data scientist has then set up their advanced visualizations and all of these different things so that they can then present it to the business. And obviously that's all housed within the Azure or AWS or Google cloud infrastructure, essentially, which is the infrastructure that it's all working on. But yeah, it's a really kind of nice diagram to show where the responsibilities lie.
Cool. Probably another one for reference for the guys when they get the PDF later.
Definitely.
They can sort of map back when they're seeing candidate profiles and understand where their sort of keywords fit into and their skills fit into the infrastructure. Great. So a little bit of a visual dump there. Maybe just talk us through some of these key tools and technologies that are being used in the market right now.
Yeah, so Hadoop is kind of the first iteration of Apache's data engineering frameworks. So it's great for kind of storing, analyzing massive amounts of data. It's not a single entity, so Hadoop's a kind of a collection of different open source tools. You'll often see HDFS. So if you're looking to write a Boolean or keyword search on LinkedIn, whatever, if you're looking for Hadoop, put HDFS in as well, which is Hadoop Distributed File System, as well as MapReduce, which is another common part of it. So that's a distributed processing engine. So it provides kind of highly scalable, easy to use data integration environment while implementing ETL with Hadoop. So Hadoop's primarily an exact transform load associated framework. We've then got Spark. So Spark's kind of the next iteration. So it's a compatible data processing platform, which, unlike MapReduce, it can be used for real-time streaming processing as well as batch processing. So not just taking one batch and moving it, but that real-time streaming that we were just talking about, Spark can handle that, whereas MapReduce associated with Hadoop can't necessarily do it. It's up to 100 times faster than MapReduce, and it seems to be in the process of displacing the Hadoop ecosystem. And I think that's definitely a market trend that we've seen as well. Like, while there's still a hell of a lot of companies using Hadoop, as Dale's touched on, like not everyone's at that real-time streaming level yet. Still absolutely a massive use for Hadoop. But given the market is shifting towards real-time, given that, you know, bigger businesses are shifting that way, you can see why Spark is increasingly popular, along with Kafka, which I'm about to touch on. But Spark also features APIs for Python, Java, Scala, and R, and it can run as a standalone platform independent of Hadoop. So it's really kind of that next step on. And then with Kafka, so Kafka is the most widely used data collection and ingestion tool. It's easy to set up. It's a really high performance platform, can stream large amounts of data into a target. like Hadoop very quickly. So what you're seeing these days is kind of Kafka and Spark used, or being the more sought after combination. But you do still see a lot of Hadoop on the market. I mean, we've still got companies that are absolutely hiring for Hadoop. So it's not dead. It's possibly just dying.
Okay. So talk us about some databases. We've mentioned SQL earlier, but talk us through the importance of databases then.
Yeah, absolutely. So I don't think we need to go into the difference between the two. I think we've covered that a lot. We've obviously got a whole session on QA and databases. I think the interesting part here is kind of historically relational databases such as DB2 or Oracle have been the standard, the kind of building blocks. But with modern applications increasingly handling, huge amounts of unstructured or semi-structured or even polymorphic, not
yeah, don't go that far.
Data in real time, non-relational databases are now coming into their own. So that's kind of like Darren touched on, your Mongo, your Cassandra, your Redis, all of that lot. So again, very, very applicable to data engineering.
Cool.
And then, a bit of analysis on the languages. So Python, as we've already touched on numerous times, very popular, very general purpose. Within data engineering and science, it's widely used for statistical analysis. So it's kind of the lingua franca for data science. According to a recent Cloud Academy survey, fluency in Python is the #1 desired skill for data engineers. And again, I think that's absolutely something we see reflected in the market. By far the most commonly sought after language for either data scientists and data engineers, I would say, which is obviously something you've already touched on, Darren. Java is used because it's high execution speeds. It's the language of choice for building large-scale data systems. It's the foundation for the data engineering efforts of companies such as Facebook and Twitter. And Hadoop is mainly written in Java. But I think, as with Hadoop and Spark, you're seeing this kind of Java, Scala migration. So Java was definitely the go-to, and it is where a lot of it came from, in the same way Hadoop was. But kind of everyone's moving towards Spark from Hadoop and Scala from Java if they can find the engineers on the market, which is still the problem. It's easy enough saying let's use Scala. You need to make sure you can actually build a team full of Scala engineers before you go and do that.
Okay. We mentioned Scala, so hit us with some Scala and then Julia.
Yeah, cool. So as we touched on, Scala is an extension of Java, so it's perfect if you are looking to move from Java to Scala. We've obviously talked about how well they work together, the fact that you can compile them very easily. Spark is actually written in Scala, so again, if we think about the market moving towards Spark, then it makes sense that Scala is also growing in popularity. And Scala code is cleaner and more concise than the Java equivalent. So it's that next step. There's a lot of correlation between Hadoop and Spark and Java and Scala. And then Julia is kind of an honorable mention, I guess. It's not super popular yet. We don't see too much demand for it, but it is being talked up a lot. So it's an up-and-coming general-purpose programming language, really easy to learn. Its speed is on par with C or Fortran, so it can be used as a single language in data projects that previously required 2 languages. So previously, you might have used Python for your prototyping, and then re-implemented that in Java or C++. Python, because really general purpose, really easy to use. You can build a prototype nice and quickly. But then when you're actually implementing it, you would probably move to Java or C++ just because they're a lot faster. Whereas Julia allows you to build that initial prototype and then deploy within that language. So it saves you having to do that crossover, requiring 2 skill sets, going to save you a bit of time. So I think we'll see Julia growing in more popularity over the next few years.
Ooh, so we've had, so impressed, Phil, we've had predictions and Latin in the final this, session today. So watch this space for updates on Julia. And so then finally, I think we're almost done, but talk us through some real life examples of data engineering that we can
yeah, so I'm not, to be fair, we've got a nice graphic after this, which would be nice to end on. So actually it's probably working quite well. So in terms of the different uses we've got there on the screen, so the first one will be using big data analytics to boost customer acquisition and retention. So Coca-Cola's one example of that. So they managed to strengthen their data strategy by building digitally led loyalty program. So essentially what they were doing is finding out who their champions in the market were, let's say, sorry. who their champions were in the market, identifying those, and then basically hitting them with a loyalty scheme so they could try and get a little bit more juice out of their existing customers, which, you know, depending how you feel about Coke, you might feel that is a little bit, you know, adding to an obesity problem. But at the end of the day, I think all they really care about is their money at the end of the day. Use of big data analytics to solve advertiser problems and offer market insights. So Netflix, I think Darren's already touched on, is a great example of this. So they use big data analytics for targeted ads. So they've got obviously 100 million subscribers. They collect huge amounts of data, so they can then use that data to help, you know, target ads towards the right person, which means that the money they get from advertisers is actually increased massively because they can give the advertiser a better return on their investment because they're able to target those ads a lot better. So yeah, we really are getting into the spooky stuff now, to be honest. We're getting into Netflix pushing ads at you, and Coke trying to trying to keep people hooked on Coke. Big data analytics for risk management. So a good example of this would be UOB Bank from Singapore. So they were kind of pioneers in using big data to drive risk management. So obviously they're a financial institution, huge chance of them incurring losses. So they basically using big data, using data scientists to predict market shortcomings, to predict risky investments, obviously using billions of data points collected over the last 10, 20 years, however it is. So looking at that type of business, that area, all of these different data points to kind of assess how likely is this to be a risky investment. You've got big data analytics as a driver for innovations and product development. So company called Amazon Fresh and Whole Foods. So I'd never actually touched on this example within Amazon, but essentially they leveraged big data to try and move into that food market. So their data-driven logistics give them a massive advantage over competitors that have been in this industry for 10, 20, 50, hundreds of years, some of them, to be honest, if we're talking about food retail. So they managed to kind of muscle into the market just by having such, you know, incredible logistics, so that they could work out, you know, when to buy the groceries in terms of how fresh they would be, how quickly to get them to people, how to get them straight from the grocer to the front door, all of these sorts of things that a supermarket really can't compete with, because obviously they're buying from the supplier, generally quite a big wholesale supplier, into the supermarket. It's then going home. So there's lots of kind of extra layers of complexity there. And then the final main use that we've seen is the use of big data in supply chain management. So we've mentioned Coca-Cola. I think we're legally obliged to mention Pepsi as well now. We don't want to be getting sued over this. So essentially, they committed to ensuring that they replenish retailers' shelves with appropriate volumes and types of products to try and bring on more retailers to the kind of Pepsi way of thinking. So they gave a commitment to anyone who was buying Pepsi that they would ensure that they kind of never ran out of Pepsi. Again, getting a little bit spooky, but they've been using big data techniques to analyze that. Obviously, look at how quickly they sell out in certain areas, how quickly they sell out in certain seasons, certain times of day, all of these sorts of things, so that they can make sure that the retailers selling Pepsi never run out and constantly have a supply to hand out, which is yeah, a little bit spooky as well. But at the end of the day, we're getting so many benefits from all of this that I think you almost have to put up with some of that little.
Okay, Phil. I think as we're almost at time, should we push forward then to the salaries? I think we've got 2 minutes, so maybe we'll flash up on the screen and then maybe go to the use case at the end. Darren, have we had any questions in the interim?
No, I think we're all good.
Okay. Did you want to comment on this one?
Yeah, so similar to the page data we had for data science, we can see here obviously Scala and Spark goes along with the data science one. So data scientists were getting paid, I think, 17% more with Spark. Data engineers 16% more. You can see Scala there is the most sought after. So yeah, you guys can have a look at this a little bit after, but it's some great data on what skills are in demand in the market.
Right.
And then finally, just to touch on this, I think there's one point I wanted to make. So in terms of skills within data engineer job listings, we'll see SQL or SQL is still there at the top. But obviously from Darren's slides, you see that SQL is actually, reducing your pay. I think what's important to focus on is SQL is still super, super useful and still is used, almost daily across all businesses. It's just if you are an SQL developer and that is your forte and that's all you do, you are increasingly finding it very, very hard to find a role within the market. But all of these guys that are using Scala and Kafka and all of these advanced stuff will still be using a bit of SQL in their day-to-day as well.
Great.
Yeah, great.
Okay. So if we haven't got any Q&A, in our final minute, let's try this one. So why do software engineers have a lot of data engineering skills on their CVs? Guys, help us understand that one.
Cool. So I think that the skills involved in data engineering still help you to kind of build great products and analyze how those products are performing, which I think is part of the most important thing. So if you are a business that is using Spark and Kafka and all of these different things to ensure that you're collecting data on your product, your software engineering team having an understanding of how these tools work is massively beneficial, because then they can work with the DS and the DE team to use the data that's already being collected to ensure that any future products they're building are built in the right way, and that the data that they generate is going to be nice and easy for the data collection tool that you're using to pull that out. So I think the term that's often used is mapping. So making sure that the data within your system is mapped out correctly so that it's really easy to extract.
Cool. Anything else on that one, Darren?
No, I think that's very succinct, and I'm mindful that we've got to the last hour. So
yeah, so thanks, guys. As ever, thanks for dialing in. Just a reminder, we'll see you next week for mobile development. So great session to join if you're, as we said at the beginning of the session, looking at iOS or Android developers, other types of mobile developers, or people with those skill sets. Thanks, Darren. Thanks, Phil, for your insights this week, and have a great rest of the week. We'll hope to see you next Tuesday. Bye for now.
Cheers, guys.
Cheers, guys. Thanks for joining. Bye-bye.